Hello, my dear students. Let us continue with our discussion on probability. We will be solving a few more questions from probability in this video lecture. Okay, so let's get started. Let me present in front of you the first question in this lecture series. Take a look at this question. It is given Avinash picks a number from the numbers 1 to 25 and found it to be an even number. The question is, what is the probability that the number that is picked by Avinash, it is equal to 12? Okay. So when I am considering the numbers from 1 to 25, we can see that 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, these 12 numbers, they all are even. So as far as this question it is concerned, when we are considering the situation here, Avinash picks a number from the numbers 1 to 25 and found it to be an even number, right? So when you see that first, or when you read that first sentence, understand that here the sample space, it corresponds to 12. The 12 possibilities are, it could be either a 2 or a 4 or a 6 or an 8 or a 10 or a 12 or a 14 or a 16 or an 18 or a 20 or a 22 or a 24. So the sample space is 12. Okay. Now, among these 12 numbers, what is the probability that it is going to be 12? So there is one favorable outcome here. So I can consider that as far as this question it is concerned, the final answer, it is option C, which is 1 by 12. The question need to be interpreted in this way. Okay, Avinash picks a number from the numbers 1 to 25 and found it to be an even number. Got it. So we can see that here 1 to 25, the sample space becomes 12. Those even numbers I have listed, out of those 12, what is the chance that it's going to be the number 12? Got it. So one favorable outcome out of total number of outcomes, that is 12. 1 by 12 is going to be the answer for this question. Okay, an easy question to start with. Let's consider the next question. A and B are two events of an experiment with respective probabilities 0.6 and 0.25. What is the probability that either of the events happen if condition number 1, A and B, they are independent? Recall, probability that A or B happens, it is probability that A happens plus probability that B happens minus probability that A and B happens. And here in the question, it is explicitly given that these two events, that is event A, event B, they are independent. In that case, P of A intersection B, that will be equal to P of A into P of B. Okay, so with these inputs, let us now consider what is the probability that either of the events happen, that is P of A or B. That will be equal to P of A, that is given as 0.6, P of B, that is given as 0.25, minus P of A intersection B, that is P of A into P of B. It comes like this. And when I'm calculating it, you can say this will be 0.6 plus 0.25 minus, that 6 into 25, it is 150, right? So 0.6 into 0.25, it will be 0.15, it will come. Okay, so upon further calculation, you can say it is 0.6 plus 0.25 minus 0.15. When I say, I can see the answer, it will come as 0.7. All right. So for this question, when A and B, they are independent, we can see P of A union B, the value will come as 0.7. Okay. For various tests, these kinds of questions, they come. So you should just remember this particular formula. And for P of A intersection B is equal to P of A into P of B when the events are given as independent. Okay. Now we have got one more question here in this set. It is said, what will be the case if A and B, they are mutually exclusive? So let us recall the same formula here. P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, but I'm just considering that formula here. Okay, but here, when the events, they are mutually exclusive, then please be aware P of A intersection B, that will be equal to 0. Okay, because happening of A will prevent the happening of B and vice versa. A and B will never happen together. That's what it means, mutually exclusive. So P of A intersection B, it will be equal to 0. Okay, so in that case, we can consider probability of A or B, that is equal to P of A plus P of B. And we can see that here the result minus 0 it will come. So that's why I didn't write 0.6 plus 0.25, it will come as 0.85. So that is going to be our answer when the events A and B, they are mutually exclusive. Okay, so that brings conclusion to this question. Let us now go ahead with the next question. Take a look at this question. It is given that a team of 4 members is to be formed from a group of 3 boys and 4 girls. So when you consider the supply, you can see 3 boys, 4 girls. Okay. Total 7 people are there. Okay. Now, it is given a team of 4 members, it is to be formed from this group. So anyway, you have to select 4 people from this 7. So the total number of outcome, that is selecting 4 from 7, that is equal to 7C4. This is the sample space. Okay, 7C4. So I'm writing that first. Now let us look at the question. The question is, what is the probability that at least 2 girls are included in the team? So we can write multiple possible situations here. It could be like 2 girls and 2 boys. It could be like 3 girls and 1 boy. It could be like 4 girls and no boys selected. See, 3 possibilities are there. Because altogether I have to select 4 members, right? So 2 plus 2, 4, 3 plus 1, 4, 4 plus 0, 4. Okay, so we can think about 3 instances here. Okay, so from 4 girls, you select 2 girls. From 3 boys, you select 2 boys. Or from 4 girls, you select 3. From 3 boys, you select 1. Or from 4 girls, you select all 4 and none of the boys are selected. Okay, so let us consider the possibilities here. Here it will be like 3C2 into 4C2. Why? Because from 3, when you are selecting 2, the number of ways it is 3C2. From 4 girls, you are selecting 2, it is 4C2. The process is complete only when you select boys and girls. That's why it's multiplication. Okay, so 3C2 into 4C2, that's for the first case. This will be 3C1 into 4C3. That is the second case. And in the third one, it is 3C0. From 3 boys, nobody is selected. And from 4 girls, all are selected. Got it. So this actually represents the number of ways you can go ahead with selecting the people. And you can see that here you are satisfying the condition, at least two girls are included in the team. Two girls or three girls or all four girls. Like that it is coming. Now let's try to add this and find what is the total that is coming here. So that will be the total number of ways the selection can be made. Okay. So 3C2 into 4C2. You know, that is 3 into 2 by 1 into 2 into 4C2. 4 into 3 upon 1 into 2 plus 3C1. 3, 4C3. It is as good as 4C1 plus 3C0. It is 1, 4C1. It is 4. Okay, so I'm just finding out the number of ways. Okay, so here I can say 3 2s are, this 2 and 2 will go off. 4 3s are 12, 12 by 2, you know, that is coming here as 6. So 6 3s are 18. We can say the number will be 18 plus 12 plus 4. When I'm adding it, you can say 6 3s are 80 plus 4 3s are 12 plus 1 4 is 4. I can see that 18 plus 12, 30 plus 4. The total number of ways this can be achieved, you know, it is equal to 34. But probability wise, when we are considering, you're asked to find 3, that is the total number of favorable outcome divided by total number of outcome. Okay, so what is 7C4? 7C4 is 7 into 6 into 5 into 4 by 1 into 2 into 3 into 4. This 4 and this 4 can be cancelled. 3 2s are 6. That can be cancelled. 7 5s are 35 you are getting. Okay. So now when we are observing it, I can see that here some calculation error I think. Let me just check. 35 anyway, total number of ways I can get this thing done. Okay. 4C1, it is 4, no? One second. 4C4 it is. Okay, that's the place where I made the mistake. Okay, let me correct it. This is 4C4. Okay, 4C4, you know, that is coming as 1. Okay, so the number of ways that I can do it, it will be 6 plus 12 plus 1 it will be. Okay, this will be 1. Okay, so 18 plus 12, 30, 30 plus 1, 31 it will be. Okay, so here I made that accidental error. Okay, so that is coming as 31. So when I am calculating the probability, I can see the total number of favorable outcome, it is 31. Out of total number of outcome, you know, that is coming as 35. So upon solving this, I am getting the result here as 31 upon 35. The total number of outcome is 7C4. I have written, which is coming as 35. Favorable outcome. These three possibilities I have listed, which upon calculation gives me the result as 31. So 31 by 35. Option C reads 31 by 35, and that is my answer. Okay. So kindly note that small error that I accidentally made. I wrote it as 4C 4. Okay, I should write it as 4C4. Okay. 4C4 is nothing but 1. Okay, so there is one way you are selecting all 4 girls, 4C4. Okay, I wrote it as 4C1, I guess, and wrote 4 over there. So that correction part alone, kindly make a note of it. But apart from that, all other things are fine. You can say the answer is 31 by 35, option number 3. Okay. Now let's go. Yes. Here it is at least 2. Here it is at least 2. Okay, so what can be done for at least 1? What you will do is find the probability that nobody is selected, and then you find out 1 minus no one is nothing but someone. That way you can do. Okay. 1 minus no girl is selected is at least one girl is selected. But here, since it is 2, we can try it that also. You first to find out what is the probability that no girl is selected. Okay. And then you can consider the situation like 1 minus no girl is selected minus exactly one girl is selected. So like that, when you do, you will be able to answer the question. Okay. Correct. Correct. So that is not there. And then go for exactly 1 minus totality minus exactly one girl is selected. Okay. So that you do, that also will get you the answer. Okay. We can try that also if you want. That I shall just quickly show it to you. What is the probability that exactly one girl it is selected? You know, the total way you can select, we have identified that it is 7C4, that is equal to 35. Exactly one girl is selected, which means it is one girl and four boys, right? One girl and three boys. What I meant is one girl and three boys, because the team strength, you know, it is equal to four. So the number of ways you can select exactly one girl, it is 4C1. The number of ways you can select three boys, only three boys are there, all are selected. So that is one. So the number of ways you can select that one girl, it is equal to four, right? So you can see that 4 by 35 will give you the probability that exactly one girl is selected. Now, the situation is not exactly one girl. It should be more than one girl, right? That's what at least two girls it corresponds to. So you can go for 1 minus 4 by 35, and that results in again 31 by 35. Okay, and that is what we got as our answer. Is it fine? I believe this is what you were asking me, and we have taken care of that. Okay, it was a good question what you have asked, so I have presented that as well. Okay, fine. Let's go to the next question. Just a second. Okay, fine. I believe the screen is now visible. There was a technical snag, I guess. The screen sharing suddenly, it got stopped. So can you please confirm whether the screen is visible? Okay. So let's continue the discussion. There are two routes that a bus can take from some Dapodi to Bopodi. Some two places are given. On the first route, it takes 20 minutes, while on the second, it takes 30 minutes. The probability that it takes the second route is 0.4. And the question is, find the expected time in which the bus covers the distance. So for these types of questions, there is a particular method that you have to adopt. Okay, so that I shall explain to you. First, you draw a table and present all these inputs in a systematic way. Okay, so we can consider that there are two routes, right? So I shall just present it. First, I am going to make a table here. Okay, so look at this. This is a route 1, and this is a route number 2. Okay. Now, in the question, two aspects we have to consider. One, the time it takes. Okay. Route 1, if you take the first route, it takes 20 minutes. And the second route, it takes 30 minutes. Okay. Now, the probability. I'm writing PROB. Okay, this is the probability part I'm talking about. It is given in the question that the probability that it takes the second root, it is 0.4. So root 2, the probability, it is 0.4. Okay. So if that is the case, the probability that the root 1, it is taken, it is 1 minus 0.4, that is equal to 0.6. If you read the question, there are two routes that a bus can take from Dapodi to Papodi. So you have to understand that these two routes alone are available. Okay, first route it is 20 minutes, second route it is 30 minutes, and the respective probabilities I have presented. Now look at the question. The question is, find the expected time in which the bus covers the distance. If you get a question of this type, please understand you are asked to calculate that expected time, right? So it is always calculated like this, expected time. That will be nothing but this root 1 time into the probability. Okay, please observe carefully. The root 1 time into the probability plus the root 2 time. Okay, what is the root 2 time? 30 minutes. Its probability, that is 0.4, whole divided by this 0.6 plus 0.4, that it is equal to 1. But anyway, I will write it 0.6 plus 0.4. For these types of questions, this is the method. Okay. There will be questions in which some kind of a gambling, it will be there. Okay, so if the guy continues to play the game forever, then what is the average earning that he can make? Okay, so like that, there are some questions. So there is something called as an expected value, it will be. Here it is expected time because you are talking in terms of time. Okay, so we can consider if you get a question of that type, just do 20 into 0.6 plus 30 into 0.4 whole divided by 0.6 by 0.4, 0.6 plus 0.4. Okay, so when I'm doing it, I can see that 20 into 0.6, it is equal to 12. 30 into 0.4, that is also equal to 12. 12 plus 12, you can see this is equal to 24. So for this particular question, the expected time in which the bus covers the distance, the answer that you have to say, it is equal to 24 minutes. Okay, and this is the standard procedure that you have to follow for answering these varieties of questions. Okay, 24 minutes. Okay, so make a note of this. Now, let's go ahead with the next question. Here it is given a bag. It contains 11 fruits, out of which 3 are spoiled. So total, it is 11. We can see that 3 of them, they are spoiled, which means the remaining 8 of them, they are good ones. Okay, good ones. So 8 plus 3, it is 11. Now, it is given 4 fruits are chosen at random. Okay, find the probability that all the fruits are spoiled. It is very evident that the number of spoiled, it is equal to 3, but you are choosing 4 fruits, right? So the question is, find the probability that all the fruits are spoiled. So when you are choosing 4, only 3 will be spoiled. All 3 will be spoiled and 1 will definitely be a good one only. Okay, so definitely as far as this question it is concerned, we can see that option A will be the answer because this is an impossible event. You got me? Because there are only 3 spoiled fruits there. You are drawing 4 fruits. So how can you say that all 4 will be spoiled? It is an impossible event. Okay. So for this question, the answer it is option A, 0. Let's consider the next question. Exactly 2 of them are spoiled. So altogether 11 fruits. 3 of them are spoiled. 8 of them, they are good ones. You are selecting 4 fruits. Now the question is, what is the probability that exactly 2 of them are spoiled? So 2 spoiled and 2 good ones. That is how the configuration it is going to be. So we can see that the 4 fruits are chosen at random. It's not one after the other. Okay. So you just put your hands and take 4 fruits. It's done in one shot. Okay. So the number of ways you can select 4 fruits from 11 available, it will be 11C4. In that 11C4 total outcome, we should have 2 spoiled ones and 2 good ones. So from 3 spoiled, how many ways you can select 2 of them spoiled? That is 3C2. From 8 good ones, in how many ways you can select 2 good ones? That will be 8C2. The work is over when you select the 2 spoiled ones and the 2 good ones. So it is multiplication. So our answer is essentially 3C2 into 8C2 by 11C4. Let's do the calculation. 3C2, it is 3 into 2 by 1 into 2 into 8C2, which is 8 into 7 by 1 into 2, whole divided by 11C4. 11C4 is 11 into 10 into 9 into 8 whole divided by 1 into 2 into 3 into 4. Okay, so let's simplify this and see what is going to be our answer. We can see that here, this 4 into 2, it gets cancelled off. You can see that here 3's are 9. Got it? And further here, this 2 and this 2 goes off. Got it? Here I can see further, this 2 is here. It cancels off with this 8, 4 times. 2 4s are 8. Further, I don't have anything to cancel, I guess. So what it remains is 3 into 4 into 7 whole divided by, in the denominator, I have 10 into 11 into this 3. So I can see that this 3 and this 3 can also be cancelled. Here this goes with 2. Here this goes with 5. Okay. So my answer will now come here as 7 2s are 14. By 5 into 11, it is 55. When I am analyzing the options, I can say 14 by 55 is here. So exactly 2 of them are spoiled. The answer, it is 14 upon 55. Okay. So please check the same. You should be getting that as the answer. Okay. Fine. Now, let us consider the next question. When 4 fruits are chosen at random, find the probability that 1 is good and 3 are spoiled. So out of 11, you can see that 3 are spoiled, 8 of them are good ones. You can see that the total number of ways you can select all the 4 fruits, it is 11C4. Okay. And in this 11C4, you are asked to check what is the chance that 1 good one and 3 of them are spoiled. So from 3 spoiled, all 3 spoiled. From 8 good ones, I have to select 1 good one. Okay, so how many ways you can do it? It is 3C3 into 8C1. So this is as good as 8 by 11C4. That is 11 into 10 into 9 into 8 by 1 into 2 into 3 into 4. So upon further simplification, you can see this 2 and this 4 cancels this 8. 3 will go in this 9 3 times. Here this will go in 2 4 times, and here in 2 this goes 5 times. So upon further simplification, I can say my answer will be 4 by 11 into 5 into 3. That is 15 into 11. 15 into 11 is 15 into 10 plus 1, that is 165. So for this question, the answer should come as 4 by 165. Option B is my choice. Okay. Now, the next question in the same, I should say the set, at least one of the fruits is good. We can say that here, altogether 4 fruits you are drawing, right? Out of which 3, no, not out of which, from total is 11. You can see that 3 of them are spoiled, 8 of them are good. So when you are drawing 4 fruits, the worst scenario that can happen is all 3 of them are spoiled, which means definitely the remaining one, it has to be the good one. Got it? So the question is, find the probability that at least one of the fruits it is good. You know what? Under any circumstances, at least one fruit, it is going to be good one only. So for this question, you have to go ahead with option B. For answering this question, you can even refer the first question what we saw. Okay, here, all the fruits are spoiled, it is 0. It means that there is at least one fruit which is good in that draw. Okay, so you can see that the first question and the last question, they support each other. And here you should mark option B as your choice. Definitely one of those fruits, what you consider, it has to be a good one. So the probability that at least one of the fruits is good, it is equal to 1. Okay. Now let's consider the next question. From a pack of cards, if 3 cards are drawn in succession without replacement. So please note this is a case of drawing the cards one after the other. Okay, the 3 cards are drawn in succession. The question is, what is the probability that the first one is an ace, the second is a king, and the third it is a jack. Okay, so we can see that here, the first one being ace, it will be 4 out of 52. Because when this guy comes for drawing the card for the first time, all 52 cards are available. Okay, that's why in the denominator I have written 52. And ace, when I consider, 4 ace cards are there, right? So I can consider that the total number of outcome is 52, favorable outcome it is 4 by 52. So the first draw, it is over. Now kindly note, it is given the first card is drawn. Okay, there is no replacement here. So when this guy goes for that second draw, there are only 51 cards available because one is already taken. He is not replacing it back. Okay. Now you can see that the second one has to be a king. All 4 kings are available somewhere in that bulk. Okay. So we can see 4 by 51 will be the answer when we are considering that second draw. That it being a king, it will be 4 by 51. Don't put 4 by 52. Okay. Now you can see that 2 cards are drawn. The first one is and the second one king. 2 cards have gone. Now you have got only 50 cards there in that bulk. Now the third one has to be jack. You can see that all the jack cards are intact. So the favorable outcome, it is 4. Out of total number, it is 50. Got it? So this will be the answer. The first one being ace and the second being king and the third being jack. I can see it is 4 into 4 into 4 by 52 into 51 into 50. Like this it will come. And on solving this, I can see the answer. How much this will come? I can see that here. Just a second. I can see that here the answer will come as 8 by 16575. Okay, I'll suggest confirm it. 4 into 4 into 4 divided by 52 into 51 into 50. Right? So when I am confirming it, yes, I am getting the result here as 8 upon 16575. Got it? So option D reads that. So for this question, you should mark option D as your answer choice. Okay. Now let's consider the next question. If two cards are selected at random from a pack of cards, what is the probability that the cards are both numbered cards or both honor cards? So here one thing you have to understand, total number of cards, it is equal to 52. Okay. So you can consider that there will be altogether 36. I'm sorry, there will be altogether half of 52. 26 red cards will be there, and we can consider that there will be altogether 26 black cards will be there. Okay. When I am considering 26 red cards, I can see that there will be 13 diamond and 13 heart. Okay, card wise 13 diamond and 13 hearts. Okay, they are the red cards. And here 26 black, when I consider 13 club and 13 spade it will be. Got it. Now the honor card, when I consider, okay, we can see that as far as this 13 hearts, when I am considering, for example, okay, ace, king, queen, jack, 4 honor cards. Diamond, when I consider, same way, 4 honor cards. Same manner, club, when I consider, 4 will be there. Ace, king, queen, and jack. Okay, and spade, when I consider, we can consider it will be also equal to 4. Okay, so 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16. 16 honor cards are there. Now, the number cards, when I am considering, you can see that 13 minus 4. When I consider that is 9. 9 number cards are there. So we can write it 9, 9, 9 and 9. Altogether, 9 fours are 36. Okay, so when you are considering these 52 cards, you can see that 16 of them, they are the honor cards, and the remaining 32 of them, okay, I can consider that, sorry, remaining 36 of them, they will be the number cards. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and 10. They are the number cards. 2, 3, 4, 5, 6, 7, 8, 9, 10. They are the number cards. 9 number cards will be there under every, I should say, set. So like that, 9, 9, 9, 9, 36 number cards and 16 honor cards. 36 plus 19 put together 52. So this is the general, I should say, the way in which the cards that we play, the total number of cards, it can be split into various categories like this. Now the question is, if two cards are selected from a random pack of cards, what is the probability that the cards are both numbered cards or both honor cards? So I can consider that the total number of outcome in this case, that will be nothing but 52C2, because the two cards are selected at random. You put your hands, you draw two of them simultaneously. So 52C2. Okay. Now the chance that both of them become numbered cards. You can see that there are 36 numbered cards, right? So 36C2 ways we can consider that both are numbered cards, or 16 honor cards are there. 16C2 ways of selecting two honor cards. So they have used the word or here. That's why I decided to go ahead with the addition. Okay. So it could be both the cards, okay, being numbers or both the cards being honor. So 36C2 plus 16C2 by 52C2. I can see that here upon simplification, this will come as 125 divided by 221. Option A is going to be my answer. Okay, you will get it like 630 plus 120 whole divided by 1326 you will get. Upon calculating, you can see that here you will be getting the final answer as 125 upon 221. Okay, now the next question, you have to be a little bit careful. The question is both honors or both hearts. That's the question. But there is one more possibility you can consider. In the hearts, honor cards are there. Okay, so you will be mainly considering that logic P of A union B. It is equal to P of A plus P of B minus P of A intersection B. Okay, so here they are asking you what is the probability that both of them are honors or hearts. So A corresponds to honors, B corresponds to hearts. Okay, there can be honors and hearts together. So that also you have to take into account. Okay, so here we can see A, I'm just defining the event, it being a honor card. Okay, B, it being the hearts. Okay, I'm just writing it. Okay. So we can see what is the probability that it's an honor card. It will be 16C2 divided by 52C2. Okay. It being the hearts, that will be 13C2 divided by 52C2. And here also you can see that there are honor cards. Here also the honor cards are there. Okay, so just to avoid the double addition, you have to go for minus. In the hearts, there are 4 honor cards, right? So exclude that. That is, it is honors and hearts. Okay, so ace, king, queen, jack of hearts. That you have to exclude. So that will be minus 4C2 divided by 52C2 it will come. So this is a classical case of P of A plus P of B minus P of A intersection B. So when you are simplifying it further, you can see as far as the second question it is concerned, this will be coming as 120 plus 78 minus 6 whole divided by 52C2, which is 1326. On calculating this, we can see the answer will come as 32 divided by 221. So we can see for this question, the answer will be option D, 32 divided by 221. Okay. So please be aware, many a time people will think of only these two aspects. They forget to subtract that double addition part. Okay. Because here you are considering, in this honor, you are considering the hearts. In this hearts, you are considering the honor. So double addition comes. So here it takes care of that. Okay. One, you are actually deleting it. Okay. So that you get, that will get you the correct answer here. So we will now consider the next question. Take a look at this question. While shuffling a pack of cards, 4 cards are accidentally dropped. Okay, so 4 fell down from that shuffling. Okay, process. The question is the probability that what is the probability that all of them are numbered cards from 2 to 10 of the same suit? Okay, so we can see that under one suit, there are 9 numbered cards, right? So we can consider all those 9 cards that was dropped, they belong to hearts. So what is the probability for that? 9C4 upon 52C4. Correct, no? Because 4 cards actually dropped. So the total number of ways that can happen, it is 52C4. In that specifically, all belong to the same suit, hearts. Okay, so the numbered card is 9 numbered cards in the hearts. You are selecting 4 of them, 9C4. So 9c4 by 52c4. That's the case when all four of them hearts. In the same way, you can consider all four of them being diamond, 9c4 by 52c4. All four of them being club, 9c4 by 52c4. All four of them being spade, 9c4 upon 52c4, right? So all of them hearts, or all of them diamond, or all of them club, or all of them spade. That is what we can see that is happening here, which we can simplify it further as 4 times 9c4 upon 52c4. As far as this question it is concerned, when we are simplifying it, it will come as 4 times 9c4 upon 52c4. Looking at the options, option A satisfy the condition, and that will be our answer here. Okay. So all of them, they belong to the same suit. This is the answer. Now there is a continuation for this question. All of them are numbered cards of different suits. Okay. So they all are numbered cards, but they belong to different suits. Okay. So there is a situation like this. Okay. The first one, you can consider that it belongs to, let me say, diamond. Okay. So 9 out of 52. It comes like this, 9 out of 52, right? But just note this. You are dropping 4 cards, right? So the number of ways this can happen, it will be 52c4. All 4 of them, you have dropped them simultaneously when you're shuffling it. So the number of ways that 4 can fall down, it is 52c4. Okay, now listen to the condition. All of those 4 cards that has fallen down, they belong to different suits. Okay, so it can happen like from heart, 9 possibilities, from club, 9 possibilities, from spade. Okay, so heart, club, spade, and diamond. So I can consider it will be like this, 9 into 9 into 9 into 9 upon 52c4, which I can write it as 9c1 the whole power 4 divided by 52c4. It comes like this. Okay. So please be aware of this calculation. Okay, the first one being hard, 9c1 ways. Not the first one I am saying. One being hard, 9c1. One being the diamond, 9c1. One being the club, 9c1. One being the spade, 9c1. So 9c1 into 9c1 into 9c1 into 9c1, that is 9c1 to the power of 4 divided by 52c4. Okay, looking at the options, I can see here the answer will come here as option B, 9c1 raised to 4 by 52c4. Option B reads it correctly. So for this question, answer is option B. It's a very interesting question. If you are familiar with how the cards are there, okay, in a well-shuffled pack of cards, then it is easy for you to solve these types of questions. Okay. Now let's consider the next question. Have a look at this. A bag contains 6 blue and 8 yellow balls. So I shall just note 6 blue, and we can see that there are altogether 8 yellow. Okay. Altogether 8 plus 6, 14 balls are there. Okay. Find the probability of drawing 2 yellow balls in succession, one after the other. Please be careful. Succession means it's one after the other. Random means you put your hands, you take 2 of them simultaneously. The difference is there. Okay. When the ball that is drawn first, it is replaced. So the first one, you are replacing it. You take it, you see what color it is, you put it back. Okay. So what is the probability that it's yellow, yellow when replacement is there? So you can see probability that it is a yellow, it is 8 out of 14. And you are putting it back. Okay. So when you are going for the second draw, again 8 yellow available, and total it is also 14. It is 8 by 14 it will come. Okay. So 8 by 14 into 8 by 14. This is what you have to calculate when you are considering the case that you are replacing it. Okay. So first you go near that bag, 8 yellow available out of 14. So 8 by 14, you can say that is the probability. And you are replacing it and going for the second draw. So there again, it is 8 by 14. Now just see the second one, there is no replacement. Okay, so it is P, Y, Y. The first one being yellow, it is 8 by 14. But please note, you took one ball. You are not placing it back. You are throwing it off. Okay, so when you go for that second draw, you can see that there are only 13 balls available. Got it? When you go for the first time, 14 are there. Okay, and then you saw what it is, you threw it off. Now you can see when you're going for that second round, only 13 balls are available because you didn't replace whatever that you have taken. Okay, now you can see that there will be altogether 7 of them which will be yellow. Because the first one yellow, you saw that and you have not replaced, you have thrown it off. So second, you have 7 yellow balls out of 13. That is the probability that when you go for the second draw, you are going to get the yellow color. So it is 8 by 14 into 7 by 13 it will come. Got it? So when I am calculating this, for the first one, 8 by 14 into 8 by 14, the result will be 16 upon 49 you will get. Option B will be my choice. And for the second one, it is 8 by 14 into 7 by 13. On further simplification, it will come as 4 upon 13. Got it? That will be my answer. So we can see that here 4 upon 13, right? I'm just checking. In 2, this will go how many times? 4 times. And 2, it will go 7 times. This 7 and 7 will cancel off. So yes, 4 by 13, it will come. Correct. Okay. So option B, 4 by 13, that is the answer here. So both these questions we have answered it. Okay. Now let's consider solve. Yep. Previous question, you are talking about this one, right? Or this one? Are you talking about this one? Ah, correct. Oh, 9C1 power 4. Okay, fine. My mistake. It has to be D. Correct, no? 9C1 raised to 4 divided by 52C4. Correct. 9C1 raised to 4. It has to be D. What you said is right. Okay. It is D. Accidentally, I marked it as B. It has to be D. Okay. This is what you were asking me, right? Yeah. It is 9. This is 9C1 to the power of 4 by 52C4. This comes correct. Okay. So this is what you have to mark. I read it as 1. That is the place. Okay. This is not the answer. It has to be D only. Okay. So good to see that you are following the discussion. Happy to note that. The answer is option D. What you said is right. I wrote it correctly here, but when I selected the option, I goofed it up. Okay. So that is for this question. And the next one, these two are over, option B and option B. Okay, I think we can now go ahead with the next question, right? Let's go ahead. Take a look at this. Oh, this is a good one. Okay, take a look at this. This is a very good one. Take a look at this question. A bag contains 6 red and 4 white balls. So I'm marking it as bag number 1. I can see that we have got 6 red and 4 white. Okay, that is there in bag number 1. And in bag number 2, it is given there are 5 red and 5 white. Okay, balls. Now look at this. If one of the bag is selected at random, and a draw of 2 balls is made at random from the bag thus selected. What a question, right? What is the probability that both the balls are white? So we can see here bag number 1, 6 plus 4, 10 balls are there. Bag number 2, 5 plus 5, 10 balls are there. Okay. So let us consider the chance that bag 1 is considered, it is 1 by 2. Okay. So now I have taken care of bag number 1, selecting bag number 1. Now in that bag number 1, I can see that altogether 10 balls are there. I have to select 2 balls, random. So the number of ways I can do it, it is 10C2. And in this 10C2, the consideration is both of them should be white. So 4 white are there, you are selecting 2 white. The number of ways you can do it, it will be 4C2. So you ended up selecting bag, probability is 1 by 2, and in that you are going ahead with selecting both of them being white, 4C2 by 10C2. Let us talk about what is the case with bag number 2. You can select bag number 2. You know the probability, it is 1 by 2. After selecting bag number 2, see, there are 10 balls in that bag number 2. You are selecting 2 balls. The number of ways you can do it, it is 10C2. And in that 10C2, both of them being white, what it is? It is 5C2. So the probability is 5C2 upon 10C2. It comes like this. Okay. So after I have written up to these points, you can see it can be bag 1 with the respective probability like this, or it is bag number 2 with respective probability like this. See this, bag 1 with probability like this, or bag 2 with probability value like this. So you have to add them together and that will fetch you the result. Okay. So here I can take 1 by 2 the common factor out. Also, just see, I'm highlighting it with green color. This is common. This 1 by 2 is common. And also, you can see this 10C2 is also common in both these terms. So I'm taking that 1 by 2 and this 1 by 10C2 out. Now I am left with 4C2 plus 5C2. Okay. Upon further simplification, I can see as far as this question it is concerned, I will be getting the answer 1 by 2 into this 10C2 is 10 into 9 by 1 into 2, that will be 45. So I shall write it here 1 by 2 into 1 by 45, this will come into 4C2 plus 5C2. 4C2 is 4 into 3 by 1 into 2, which is equal to 6. 5C2 is 5 into 4 by 1 into 2, you know, that is equal to 10. So this is basically 16 divided by 45 into 2, that is equal to 90. Cancellation with 2 will fetch me 8 out of 45. So when I'm observing the options, you can say option B, it reads 8 out of 45. And that is my answer, the final answer for this question. Please have a look at this question. It's a very amazing question. And you can use this for your further follow-up. Okay. Make a note of this. You are selecting the bag. What is the probability? And after selecting the bag, further you are proceeding. Okay. With the 2 whites, 4C2 by 10C2. And then you go to bag, consider bag number 2, 1 by 2, 5C2 by 10C2. Put together, you get the result. Okay. So that's for this question. Let's now go to the next one. From a bag that contains 2 pears, okay, 3 peach, and 4 fig. What is happening? Total is 4, 5, 6, 7, 8, 9. 9 are there in total. 3 fruits are drawn at random. Random means what? You put your hands and then you select all 3 together. So the total number of outcome, that will be 9C3. The total number of ways you can select the three fruits from 9 available is 9C3. 9C3, when you are considering, it is equal to 84. Okay. So just be aware of this 84. 9 into 8 into 7 by 1 into 2 into 3. 9 into 8 into 7 by 1 into 2 into 3. When you do, you can say 3 3s are 9. This 2 will go in this 8 4 times. So 12 into 7, 84 you will get. So the total number of ways that you can draw three fruits from 9 available, it is 84. Let this be here. Okay. Now the question number 1. What is the probability that all the three fruits are of the same variety? Okay. So we can consider 3 peach. Okay. Otherwise it could be 3 fig. Pear not possible because only 2 pears are there. Since you are drawing 3 fruits, all 3 of the same variety, when you are considering, the 2 pear won't come. So it could be like 3 peach available, you select all 3, or 4 fig available, you select 3 out of total, that is equal to 84. So these are the favorable outcome in the numerator out of total number of outcome. You know the 3C3 is 1, 4C3 is 4 by 84. So for the first question, my answer will be 5 upon 84. Okay, looking at the options, you can say 5 by 84 is what option A reads. So for this set of questions, option A is my choice, the first one. Okay, now let us focus on the second one that is presented. Exactly two of them, they belong to the same variety. So I can think of possibility like this. 2 pear and one other. Or it will be 2 peach and one other. Or it will be 2 fig and one other out of this 84. How many ways this can happen? There are 2 pear, you are selecting 2 out of that. 2C2 and one other. One other, when I say, we are talking about 3 peach plus 4 fig, 7 fruits. From that 7, you are selecting 1. So this is corresponding to the 2 pear and one other. Okay. Or, so that's why the plus symbol. 2 peach. 2 peach from 3 available, you can select it in 3C2 ways. And you have already considered the peach. Okay, in this second case, 3C2. What is remaining? 4 plus 2, 6 is remaining. You have to select one other from that 6. So that will be 6C1. Please be aware here, 3 peach, from that you are selecting 2. Okay, so you have selected 2. Now you can consider the 2 pear and 4 fig. 4 plus 2, 6 there, the 6 others, from that you are selecting 1. Okay, that is the second possibility. Or, now the final one, it is about 2 fig and one other. 4 figs are there, you end up selecting 2 figs. The number of ways that you can do it, it is 4C2. And you can see other than fig, 3 plus 2, 5. 5 fruits are there, you end up selecting 1. So that is 5C1. Got it? Whole divided by. So the 3 fruits are selected under the favorable condition out of 84. You have to consider. Okay. So when you are simplifying this 7C2, sorry, 2C2 into 7C1 plus 3C2 into 6C1, that you have to anyway do. So when you are doing it, you can say my answer will come here as 55 out of 84. That's what it will come. Looking at the options, you can see that option B, it reads 55 by 84. And for this set of questions, option B is going to be my answer choice. Okay. Now, the last one, that is actually a very simple one. They are considering all the three fruits are of different varieties. So please be aware the total number of outcome, it is 84. In that 84, you are considering one pear, one peach, and one fig. How many ways you can do it? 2C1 ways you can deal with selecting one pear. 3C1 ways you can consider selecting one peach. 4C1 ways of selecting the one fig. You have to select a pear and a peach and a fig. Okay, the logic is and. That's why multiplication. So this will be 2 into 3 into 4 whole divided by 84. 4 3s are 12. It will go in 84 7 times. You can say my answer will come as 2 upon 7. Okay. So for the question that I have presented, you can say the answer will come as 2 by 7. Option C is my choice. Please make a note of it. Okay. Now let's consider another question. The odds in favor of Saurabh getting a final selection into a B school, 5 to 7. And the odds against Sweth getting it are 4 to 3. So if you see a sentence like this, you should actually know how to interpret odds in favor. It is given that it is 5 to 7. How to interpret it? Okay, so I shall just write it here. Probability that Saurabh is in. That is equal to 5 by 5 plus 7, 12. And probability that Saurabh does not get selected, that will be 7 upon 12. So that is how odds in favor, it becomes 5 by 12 is to 7 by 12. It comes as 5 to 7. Okay, this is a very important step that you are taking. The odds in favor of Saurabh getting selected into the B school, it is given as 5 to 7, which means probability that Saurabh gets selected, it will be 5 upon 5 plus 7, that is equal to 12. So probability that Saurabh won't get selected, that will be 7 by 12. Now, the same way, read it carefully. The odds against Sweth getting it are 4 to 3. So probability that Sweth is not going to get selected, that is equal to 4 by 4 plus 3, 7. Because odds against is what given as 4 to 3. So he won't get selected. It will be 4 divided by 4 plus 3. That is coming as 7. Which means probability that our Sweth is going to get selected, that will be equal to 3 upon 7. Okay. So we got all these inputs now. Now look at the first question. What is the probability that at least one of them gets a final selection in the B school? So for answering this question, the classical method is you find out what is the probability that none got selected. Okay. That is both our Saurabh lost and our Sweth also lost. None got selected. That will be 7 by 12. That is Saurabh didn't get select. Sweth didn't get select. It is 4 by 7. You can see that none got selected. It is coming here as 1 by 3. But if you read the question carefully, it is not asking you to consider what is the probability that nobody got selected. It's asking you to consider that at least one of them got a final selection. It is not this 1 by 3. That's what we could understand. So can you tell me what will be our answer? The probability that at least one of them is getting the selection. It is 1 minus 1 by 3. I can say that will be coming here as 2 by 3. Okay, so that is my answer for the first question. Okay, now look at the next one. Find the probability that exactly one of them gets a final selection. So they are insisting that only one is getting selected. So how you can consider probability that Saurabh is in and our Shwet is out. Okay. Or they are asking you to find what is the probability that Saurabh is out and our Shwet is in. Please be aware of this, okay? They are asking you to find what is the probability that Saurabh is in and Shwet is out, or what is the probability that Saurabh is out and Shwet is in? Because exactly one of them should be getting the final selection. So now it is easy. Probability that Saurabh gets selected is how much? It is 5 by 12. And Suresh not getting selected. Sorry, Shwet not getting selected. It is 4 by 7. Please observe, it is 5 by 12 into 4 by 7 plus the probability that Saurabh didn't get select. What is that? It is 7 by 12. Okay. And the probability that Shwet got selected, that is 3 by 7. Please observe, it is calculated as 5 by 12 into 4 by 7 plus 7 by 12 into 3 by 7. So that is the reason why I wrote it like this. Got selection on this side, didn't get selected on the other side. So this will help you to see it as 5 by 12 into 4 by 7 plus 3 by 7 into 7 by 12. Okay, let us go ahead with the simplification. You can see that 4, it will go in 12 3 times. This 7 will get cancelled off. This 3 will go in this 12, 4 times. So on further simplification, you can say this will be 5 by 21 plus 1 by 4. We can see here the final answer. It will be coming as 41 divided by 84. Okay, 41 upon 84. That is going to be my final answer as far as this question it is concerned. Okay, fine. So with this question, we will conclude our lecture number 2 on this topic, that is probability. In this video, we have explained a good set of questions that covers some fundamental aspects like P of A union B, P of A intersection B, expected value, team selection or team formation with certain constraints and considerations. All those things we have discussed. Okay. Now, more questions related to this, we will be considering it in our subsequent discussions. So with this question and this note, I would like to conclude today's session over here. If you have got any doubts or any queries that you wish to share with me, you may do that now. Thank you.